everyone, my name is Bharti Jain. In my previous lectures, we have seen how to expand determinants and also the different properties of determinants. Now in this lecture, we will see how to use this property to solve different questions. So let us see questions from exercise 4.2. I hope you all have solved all the examples based on these properties. So after solving these examples, we can now come to this exercise 4.2. So question number 1 of this exercise is that you have to prove this determinant equal to 0. Now we have seen in the properties that if you have to prove any determinant equal to 0. So there is a property related to this, that is, if any two rows or columns are identical, then the value of determinant becomes equals to 0. Okay. So you can either solve this determinant by using that property, that is making it equal to 0 by this making any two columns or rows identical, or there are some other ways also. Okay, let us see. See here this column 3 is expressed as the sum of two terms. So you can express actually this determinant as the sum of two determinants by using our property. So you can write this as what? X, Y, Z, A, B, C, then X, Y, Z and plus. Now you can split this column by using property, that is A, B, C and again A, B and C. Now here you will see that this C1 is equal to C3 in this determinant, and in this determinant C2 is equal to C3. So both these determinants will be equal to 0. So it is equal to 0 plus 0 and that is finally equal to 0. Okay, is it clear? So in this way you can prove it equal to 0. There is another way also. Actually when you will add C1 and C2, then you will get what in C1? X plus A, Y plus B and Z plus C, and that is equal to C3. So which will make these two columns also identical. So by this method also you can solve. Okay, now come to question number 2. So question number 2 is this. Again you have to prove it equal to 0 and only using properties. So first you observe this determinant. So when you will observe, you will find some terms in this determinant, that is if you add all the rows or if you add all the columns, actually you will get zeros, because here you will find one pattern, that here it is minus B, it is plus B, it is plus A, here minus A, it is minus C and here it is plus C. Okay, so either you add about rows or about columns. So let us change this R1 to R1 plus R2 plus R3. So you will get what? It is equal to A minus B plus B minus C plus C minus A. Okay, then other two terms will be same. Then come to C2. So you are changing R1. So it will be B minus C plus C minus A plus A minus B, and then C minus A minus B. Okay. So and the last term will be what? You can solve here, C minus A plus A minus B plus B minus C. So it will be equal to 0. Here also you will find that it is minus B, it is plus B, it is minus C plus C minus A plus A, and here also same thing, plus B minus C plus C minus A plus A. So the row 1 has become equal to 0. So now you can write this row equal to 0. So it is equal to what? 0, 0 and 0. Then in the next row it is B minus C, C minus A minus B, then C minus A minus B, and B minus C, and that is equal to 0. Okay, so hence proved this question also. Now come to question number 3. Now question number 3 is, see, in all the questions you will find variety of this methods and different properties you have to use. More number of questions you solve, more idea you will get how to solve these questions. Okay, so you solve all the questions. Now question number 3 is 2, 3, 5, 7, 8, 9, 65, 75 and 86. So again this you have to prove equal to 0. Okay. So this is a different type of problem. Now you will see that this C3 you can write like this. See, it is 65, no? So 65 can be written as 7 into 9 plus 2. Same way, 8 into 9 plus 3 is equal to 75. Then 9 into 9 is 81 plus 5 gives you 86. So here you can write this column 3 as what? So it will be 7 into 9, 63 plus 2. Here 8 into 9, 72 plus 3, 35. Here 9 into 9, 81 plus 5, 86. Okay. Now you can express this determinant as the sum of two determinants. Okay. So it will be what? 2, 3, 5, 7, 8, 9. And write this as it is. 7 into 9, 8 into 9 and 9 into 9. Okay. Then plus next remaining term you have is 7, 2, 7, 2, then 3, 8, 3, 5, 9, 5. Okay. So one more thing you can see here, that from this determinant you can take out common 9. So if you will take out common 9 from here, it will become what? See, we are taking out common 9. Now you can see here that C2 is equal to C3 and here C1 is equal to C3. So again it is equal to 0 plus 0 and that is again equal to 0. Is it clear? So this was a different type of problem. Now come to next question. So in all these questions you will find that if you have to prove this equal to 0, most of the time you are making any two rows or columns identical. Now come to question number 4. So it is 1, 1, 1. All of you note down BC, CA, AB, BC, CA and AB, and you have A into B plus C, B into C plus A and C into A plus B. This also you have to prove it equal to 0. So first of all let us simplify by opening this bracket. So it is equal to 1, 1, 1, BC, CA, AB, and here it is AB plus AC, BC plus AB and CA plus CB. Now you can observe that if you change C2 to C2 plus C3, you will get what? AB plus BC plus AC, AB plus BC plus AC, and same way here also. So you will get 1, 1, 1. Then C2 is changed to AB plus DC plus AC, AB plus BC plus AC, then AB plus BC and plus AC. And here you can write this as it is, AB plus AC, BC plus AB and CA plus CB. Now if you take out common from this C2, AB plus BC plus CA, you will get 1, 1, 1, 1, 1, 1 and same AB plus AC, BC plus AB and CA plus CB. Okay. So now as these two columns are identical, so the whole determinant will equal to 0. So it is equal to 0. Hence proved. Okay. Is it clear to you all? Yes. Good. Okay. Now come to question number 5. So question number 5 is this. In this question you will observe this thing that here in each row and each column it is a sum of two terms, but finally you are getting single terms. That means you have obtained this by subtracting some rows or columns. So let us change. Here you have B plus C and here you have this A plus B, or you can subtract, if you will subtract these two you will get B minus A. Okay, good. So let us make change, that is change R1 to R1 minus R2. So you will get what? So only R1 will change. So B plus C minus A minus B. So it will be R1 minus R2 means B minus A. Okay. Then Q plus R minus P means Q minus P. Then Y plus Z minus Z means Y minus X. Okay. Then same you have to write C plus A plus B, R plus P, P plus Q, Z plus X and X plus Y. Okay. Now here you have minus A, so you can use this R1 plus R3 to remove this A, you will get only B. So you can change this R1 to R1 plus R3. So it is equal to what? B minus A plus A cancelled means 2B, and here you have 2Q and here you have 2Y. Then C plus A plus B, R plus P, P plus Q, then Z plus X and X plus Y. Okay. So now you have single terms in the first row. Now we can take out common 2 from row 1. ठीक है, तो ले लें row 1 से 2 को common. So after taking out common 2, it will be like this. Now you can remove this B, Q and Y from this R3 by using R1. So you can change R3 to R3 minus R1. Okay. So it will be now B, Q, Y, then C plus A, R plus P and Z plus X. Now here it will be only A, P and X. Okay. Now only R2 is left. So R2 can be changed by applying R2 minus R3. Okay. तब आपका क्या आ गया? B, Q, Y, and 2 was also common because we have taken out from here 2. Now it will be C, R, Z, A, P and X. But in the proof it was APX is in the first row, then BQY is in the second row. So you can interchange these rows by using our property. You can interchange R1 to R3, but then this will be multiplied by -1, means sign will be changed. So APX, BQY and CRZ. Again we want this in the second row, so again interchanging R2 and R3. So again that will be multiplied by -1, so it will be again 2APX, then BC, PQ, R, XY, Z. Okay, so it is proved what we want. Okay, is it clear? Now come to question number 6. So question number 6 is, all of you note down question number 6. So it is 0A minus B. First row is 0A minus B, then minus A, 0 minus C, then B, C and 0. B, C and 0. So one thing you will observe in this determinant, in this matrix, is that it is skew symmetric. It is actually skew symmetric. So first you observe this determinant. You will find that here in the row 1, C is not there. In row 2, B is not there. In row 3, A is not there. Okay, so you can multiply these rows by this A, B and C. So let us multiply, or you can write it, change R2 to R2 make an A, B, R2 to B, R2 and R3 to C, no, A, R3. Okay, but if we are multiplying any term in the determinant, you have to divide also. So we have to divide this by AB. Okay, so now you have 0 A minus B, then it is multiplied by B, means minus AB, 0 minus BC, and it is multiplied by A, means AB, AC and 0. So now you can get one more 0 by adding R2 and R3. So change R2 to R2 plus R3. So you will get one more 0 about this row, column 1. So it is equal to 1 upon AB, 0 A minus B. So you are changing R2, means 0 AC and minus BC, then AB, AC and 0. Now you can expand about this. Which column? Expanding about C1. Expanding about C1, you will get what? 1 upon AB, then it is AB into minus ABC and plus ABC. So 0, that is equal to 0, hence proved. Okay, is it clear? Now come to question number 7. Question number 7 is minus A square AB AC, then BA minus B square, then BC, then CA, CB and CA, CBN minus C square. and that is equal to 4a square b square c square. It is equal to 4a square b square c square. Okay, so now you first see what you have to prove. So you have to prove this equal to 4a square b square c square. So we can observe from this determinant that we can take out common a either from this row also or from this column also. Similarly, b from this row 2 and c from this R3. Okay, so taking out common. So taking out common a, b and c from R1, R2 and R3 respectively. So we have what? So a is common. Now left is minus a. Okay, now let us come to question number 7. So question number 7 is that you have to prove it equal to 4a square b square c square. It means, so you will be taking out common a square b square c square from this determinant. So if you observe this determinant, you will find that a, b and c are, you can take out common from this rows or either column wise also. So taking out common a, b and c from R1, R2 and R3 respectively, you have what? So taking out common a, b and c, you have minus a, b, c. Then from row 2 you are taking out common b, so you are left with a minus b and c. And here from R3 you are taking out common c, so it will be a, b and minus c. Now again you will observe that you can take out common a, b and c from C1, C2 and C3. Okay. So again taking out common a, b, c from C1, C2 and C3. So you will write again taking out common a, b and c from C1, C2 and C3. Okay. So you will get what? So it is equal to a square b square c square minus 1, 1, 1, 1, 1, minus 1, 1, 1, minus 1. Okay. So now either you can expand it directly to get RHS or you can get 1 or 2 zeros. So you can see that from this we can get 1 0 by applying C1 is changed to C1 plus C2. After this you will get 1 0. I think 2 zeros you will get. So a square, b square, c square, 0, 0, 1, 1 minus 1, 1, 1, 1 and minus 1. Now if you will expand it about this C1, you will get 4 a square, b square and c square. Okay, is it clear? So this was your question number 7. Now come to question number 8. So question number 8 is you have to, this question is 1a, a square, 1b, b square and 1c, c square. All of you note down this question. So here in all the questions you will observe one thing, that you can see in the RHS that what you want. You want actually a minus b, b minus c and c minus a. So a minus b you can get from what? By changing R1 to R1 minus R2. और b minus c आपको कैसे मिलेगा? That is by changing R2 to R2 माइनस R3, ठीक है। तो आप अपने हिसाब से कोई भी ट्रांसफॉर्मेशन लगा सकते हैं और ये ला सकते हैं। सो नाउ यू हैव व्हाट, लेट अस फर्स्ट चेंज R1 to R1 minus R2. So you have what? So R1 minus R2 means 0, A minus B, A square minus B square, then 1 B, B square, 1 C and C square. Now again applying, that is changing R2 to R2 minus R3. So you have what? 0, 1, no, it will be 0, A minus B. Now you can write this as A minus B into A plus B. Okay. Now you are changing R2 to R2 minus R3. Okay. So this will be 0, then B minus C, and this B square minus C square, then 1 C and C square. Now you can take out common A minus B from this and B minus C from this row. Okay, that only we want. So taking out common. So taking out common, A minus B from R1 and R2 से क्या कॉमन लिया? B minus C and B minus C from R2, ठीक है। So you will get what? A minus B, B minus C, and you have 0, 0, then A minus B is common, then A plus B, then 1, here also it will be B plus C, then 1 C and C square. Okay. Now you have got 2 zeros in C1. Okay. So now you expand this about C1 and you will get this required answer. Is it clear? So this last step you will be doing yourself. Okay. So this last step you do yourself, and actually all the questions are set accordingly. अगर आप अच्छे से इसको solve करेंगे तो you will definitely get the answer. Okay. Okay. Now come to next question. So you complete this question, all of you. Yes. So now come to the second part of this. So second part of this is just similar to this. Only you have to prove it equal to A minus B, B minus C, C minus A and A plus B plus C. So in this next question also, means the same question, second part, same type of operations you have to do. Means जब आपको B minus C लाना है तो आप क्या करेंगे? Second part also. Okay. Now come to question number 9. So question number 9, all of you note down, is X, Y, Z, X square, Y square, Z square, then YZ, ZX and XY. It is equal to X minus Y, Y minus Z, Z minus X and XY plus YZ plus ZX. XY plus YZ plus ZX. Okay. Now you tell me. Now you want X minus Y. So what you will be doing? Yes. So XY means X minus Y you will get from R1 minus R2. Okay. Then Y minus Z you will get from R2 minus R3. ठीक है, अभी इतना करते हैं फिर आगे देखते हैं क्या आता है. ओके, सो चेंज R1 to R1 minus R2. So you will have what? x minus y, x square minus y square, and yz minus zx means z common and y minus x. Okay, then you have y square, zx, z square, xy. Okay, now you will apply, change R2 to R2 minus R3. Okay, so it is equal to x minus y, x square minus y square, you can write as x minus y into x plus y, then z into y minus x, and then so you are changing R2, it will be now y minus z, y square minus z square, and here you have common x and z minus y, then you have z square and xy. Okay, now you can take out common x minus y from row 1 and y minus z from row 2. So taking out common x minus y from R1 and y minus z from R2. Okay, now let us see what happens. Okay, so now you have x minus y, y minus z, and 1 x plus y and minus z, then y minus z from R2, so 1 y plus z and minus x. Okay, then last one z square and xy. Okay, so now you are left with x minus y over y minus z. Okay, now z minus x you want. Okay, so z minus x you will get from here, isn't it? So let us change R1 to R1 minus R2. ठीक है, मिल जाएगा आपको. So it is equal to x minus y, y minus z, and R1 minus R2 आपका आ गया 0. Then x plus y minus z means x minus z, and here also you will have x minus z 1 y plus z minus x z square and xy. Now again take out common x minus z from this. So taking out common, so actually you want z minus x common, so take out common z minus x. So taking out common z minus x from R1, so you have x minus y, y minus z and z minus x into, so 1, it will be minus 1, minus 1, 1 y plus z minus x z square and xy. Okay, so you can either you can expand it now about this row 1 or C1, or you can get one more 0 by changing this. You can change C2 to C2 minus C3. So you will get one more 0 here, and then about that you can expand. Okay. So let us complete this question. So now you are using C2 minus C3. So it is equal to x minus y, y minus z, and z minus x into, then C2 minus C3 means 0, 1, z, then again 0, then x plus y plus z, then z square minus xy, then minus 1 minus x and xy. Okay, now expanding about which column or row? So yes, expanding about R1 because it has two zeros. Okay, so it is equal to x minus y, y minus z, z minus x into, so it will be minus 1 into z square minus xy minus zx minus yz minus z square. Okay, so z square and minus z square is cancelled and you are left with xy plus yz plus zx because minus 1 is common here, and that is the RHS. Okay, is it clear? So question number, this was question number 9. Okay.